Hi everyone, my name is Andriana and I'm marketing specialist at Intellias. We are here to listen to a presentation on a topic Lambda Launch, a comprehensive introduction. But before we start and while others are joining in, I'd like to introduce you our company, Intellias. So who we are. Intellias is a technology enabler for the world leading companies, interesting project, international clients, and 8 development centers in the world. This is what we are about. Intellias is creating a unique software solution for more than 2 billion people in the world with the help of 3,000 experienced specialists on the board. And if you would like to join us on that road, please check our vacancies in the link that I sent in the chat. And now a few technical moments. I'd like to emphasize on the fact that you can ask questions using our chat and our speaker will answer them in the end of the presentation. So that's all what I wanted to say now. Our speaker today is Yaroslav Senko, Java lead at Intellias. Please, Yaroslav, stage is yours.
Okay, thank you very much. Hi everybody, I'm going to share my screen with the presentation. Please let me know when you will see it.
Yeah, we can see it.
Okay, thank you very much. Today's talk is about AWS Lambda. I couldn't say that you will hear something special. It's just something, the lecture that will help you to understand what is it, might be fill some gaps about lambdas, might be find new tools about it, and might be find new use cases for it. So the topics that I'm going to describe here, what is the AWS Lambda, its main features, use cases, execution environment, life cycle, concurrency, code reusability and Lambda layers, versioning, CI/CD, monitoring, troubleshooting, debugging, and best practices of usages of the Lambda. So let's start. What is the Lambda? It's secure, on-demand, event-driven computer service that scales very rapidly, built only for what is used, and supports most of the actual programming languages. Let's dive into this a little bit deeper. What does it mean, secure and on-demand computer service? Here on the screen, you see a bunch of aspects that every developer should care about if it develop and promote usual, not Lambda web application. And I won't list all of them, but AWS service provide some of them on demand. So if you use Lambdas, you won't care about infrastructure security, server management, load balancing, web server, firewall at all. It's part of the AWS Lambda service, and AWS care about it for us and provide it for us. In the second column, we have some services that isn't part of the AWS Lambda environment, but such services exist in AWS as part of AWS Common, and they could be very easily reused and set it up. About these services, we all developers will have to set them up, to care about them, pay for them, of course, but they shouldn't develop them or deploy it somewhere by their own. These services already exist, they are well tested, and could be used as a service. So this allows the Lambda developers to concentrate on business logic of the application. Next, Lambda is event-driven. What does it mean? While Lambda starts only when some event occurs, the event to which Lambda is subscribed. There is a really huge amount of different events. Here you can see events from API Gateway, Amazon S3 Bucket, Amazon DynamoDB, Kinesis, but it's just a sample. There are really a big amount of the event to which Lambda could be subscribed, and Lambda will start run, will raise up only when event occurs. When there is no event, no Lambdas will run in, and of course, developers or company won't pay for this time. And by default, Lambda allows to run about 1,000 instances per account, but this number could be increased by special event, and during initial burst, Lambda raises from 500 to 3,000 Lambda instances during the first minute. It depends on the AWS region and hub where Lambda is promoted, and also Lambda allows to raise up 500 instances every minute after the first. Here you can see the list of the supported languages. I won't read it, but I would like to mention that Lambda allows to run any Docker image inside Lambda service. You can just create it, put it in Docker Hub or in AWS Docker Images Hub, and run it inside Lambda as a Lambda service. And this allows us not used only those languages that mentioned earlier, but it allows us to run anything and anywhere. It could be scripts, it's anything. The main features, here is the list. I won't read it in full, but I would stop on the main features of the Lambda. Of course, the first one is extend other AWS services. It allows to tune behavior of other services, to connect different services between each other, and add any additional functionality. Also, I would mention that automatic scaling, that developers don't have to care about it. And also AWS allows to orchestrate multiple functions. What does it mean, orchestrate? It allows to create chains of Lambda invocations when the first Lambda complete its task and the next one started to continue something and to add a little bit more functionality. For me, it was really interesting to check special Graviton 2 processor. It was developed by AWS and mentioned that it's really very fast and it's much cheaper than usual ones. But Personally, me, I haven't seen such effect, but I couldn't say that I did any tests, etc. And might be that's it from the main feature that I would like to admit. It doesn't mean that all others not so good or not so useful, but it's just my opinion on it. Let's go through main use cases. As I mentioned, I would like to mention that this list of main use cases is mine. It's little bit different from official documentation, and it's some kind of my vision to AWS Lambdas and how them could be used. The first one, it's use case is the first one. It's in my mind, main Lambda main Lambda use case. It's just joining the different other AWS service between each other. We can see here the flow when the first Lambda in serverless application store video stream to the S3 bucket, and all other Lambdas are subscribed to different S3 buckets events. And when we store video file in the first one, the second Lambda creates request or starts recognition flow just to recognize person on the video, make compare it with ID, some identification function. The second Lambda in the same time, in parallel, concurrently, start creating audio stream from the video stream. It's AWS Elastic Transcoder service. The result of working on this service is also put it into other S3 Lambda, and the next Lambda get these results, prepare data for transcribe service. Transcribe service create text file from the audio stream and also put it into the bucket. Next Lambda analyze result and prepare income data for the next iteration, put it into S3 bucket, and the last one starts a Lambda extract service that allows to analyze which collocations during this person's speech was stressed, how that was used, some kind of logical analysis. You can see that there is 3 AI services, AWS, and this flow was developed during, I think, 2 weeks or 3, and will take a lot of time for development, and it is possible only because of Lambda. In this use case, Lambda integrates different services between each other, and this one is just a sample. There are tons of other samples how it could integrate different services between each other. Other use cases, it's utility method. For example, if we will have a look on the picture, how we can resize image flow when user ask image with specialized size. There is no such image in S3 bucket. Then user was redirected to API gateway, which invokes Lambda. Lambda resized the image and put it into S3 bucket, return response, and user is able to load it. It's some kind of utility, small functions for which it's strange to develop separate microservice or application, but this stuff should be done. And AWS Lambda is the best way how it could be implemented. In another part, it just another usage of the Lambda. It's AWS services hooks. There are a lot of services that allows Lambda to allows using Lambda customize their behavior. It's here I provided the table with possible hooks for AWS Cognito service. It's analog of the kick lock, and as you can see, there are different points for integration, for customizations from in different parts. It allows to customize emails sent to new users. It allows to customize GWT token creation, etc., etc. And here you are on this image. You can see how it looks in reality. It's simplified version of one of the projects, and here you see how Lambda is used for security purposes. There are 3 Lambdas, which is AWS Cognito hooks. One of them customized event messages when new user was created. Second one made pre-authentication validation, and the third one is took part in token generation. It allows to put inside GWT JOT token additional information that could be used in the application behavior. And the last Lambda, it's not Java, it's not Cognito hook, it's hook to API gateway. And this Lambda allows to us to check authorization flow. For example, is current user is allowed to make given action. It could be based on role model, it could data or any other model, and inside Lambda we can put any logic, and any request that goes through API gateway will invoke this Lambda. Lambda, in our example, it's DynamoDB, load data about user, about what is allowed for him, what is not allowed, and make a decision. Either this request will be propagated to the microservice, or authorization error response will be sent. Here you are. You can see just simplified diagram of the serverless backend based on Lambda. We also have REST API and API gateway, Lambda that allows to check different security things, and Lambda as a microservice or main point. This Lambda could work with user tables, DynamoDB, any data storage or something like this. And from my point of view, and from my experience of working with serverless applications, there are several challenges for these applications, and one of them is that AWS doesn't provide DB connection pool for most of databases except the AWS Aurora, and this brings other tricks and other challenges that developers should care about. For example, if one Lambda function was invoked twice in a row in a very short time, it is possible that connection will be, as soon as Lambda will be hot, and connection will live in the same state as it was during previous invocation, and some kind of state leaks about which all developers should care. The next challenge is Lambda code structure. AWS doesn't provide any framework or architect structure, where to put business logic, where where database layer should be located, when the response should be handled. And I've seen the code that when in one single file there is processing of the HTTP request, connection to database, business logic. Such files became big and messy, and it's really hard to work with it. Yeah. One more thing is hard to reuse code. Yes, Lambda provides mechanism to share code. It's Lambda layers, but this mechanism have different limitations. Yes, it has different limitations. And the last challenge that I'm seeing in serverless applications, it's database design. If we will have a look into microservice world, yeah, each microservice has either its own database or its own separate database schema, yeah. But Lambda, serverless Lambda functionality is too small, and there is no possibility, for example, to implement in one Lambda CRUD operations, etc. And because of this, there is no boundaries how to divide database for services, and it will look strange if we will divide it in different areas, business areas, but it will be a really challenge. Another way is just to use one database for all Lambdas, and it's very similar how monolith applications use it. But in this way, we won't have separated data, and this approach has several disadvantages. That's it about my impressions from working with serverless backends. Let's move to another use case. It's stream processing. AWS provides possibility to work with two different streams. The first one is DynamoDB stream. It's just, if we will simplify it, we can have a look of the log data of database actions. When any update, any action on database is sent to the stream, and it is possible to, for example, to store it in the Amazon S3 bucket if we need it. The second case, it's Kinesis, working with Kinesis. Kinesis data warehouse invokes transformation, Lambda function synchronously, which returns the transformed data back to service. We can have a look into this process a little bit more deeper. Here you can see Kinesis and its shard, a Lambda service, and Lambda function itself. Lambda function pulls kinesis shard into the butcher, and invoker invoked Lambda function, and it processes this data batch. Batch size could be, of course, configurable, and this use case is very similar to Kafka streaming API when we have consumer, transformer, and producer to other Kafka topic. Let's speak a little bit about execution environment. Lambda service execution environment consists from runtime function. It's the Lambda function itself and the data and code that you run it inside it. Extensions. Extension could be any application, script that runs in the same thread with the Lambda, or it could run in a background thread. And in this application, in this extension, it is possible to put different functionality. Usually, it's used for telemetry and to log some data, capture some information about Lambda behavior. But I've seen such pretty strange usages when inside Lambda extension were Vault, and Lambda function take data from this Vault. I don't know why, for which purposes, because AWS have separate service, not extension, based created upon the Vault, but such extension exists. Runtime API, it's allows Lambda to receive events and response back. Extension API, tightly integration to environment and allows to register functions for all Lambda lifecycle events. So, for example, start a new process, send in response, some logic, etc. And telemetry API allows extensions to receive from Lambda logs, metrics, traces, etc. Here you can see Lambda lifecycle. It is in extension init. It's init phase. Firstly, the Lambda service initialize extensions, then runtime. After this, it initialize Lambda function itself. Then a Lambda function will be invoked. If Lambda function will be invoked 2 times, the same Lambda function invoked 2 times in a row in a very short period, you can see that the runtime, that init phase will be omitted, and Lambda will start from this point. This approach is named as hot start, when you don't need to run all environment, and Lambda function is invoked almost immediately. And here you are, the shutdown. Firstly, runtime is shut down, then extensions. If during Lambda function invocation was sent any exception on any error, Lambda shut down everything. Lambda service shut down everything, extension, runtime, etc. And it will raise up and starts from the very beginning. Also, there is one more phase. It's restore phase, or snap start, another name of it, and it's created for Java only, and this allows to start Lambda not by initialization extension, runtime, etc., but start Lambda when everything is loaded inside the memory kept somewhere on the disk, and when Lambda is invoked, a Lambda service found this memory snapshot, loaded into the environment, and run it. Here we can have a look to Lambda concurrency. What in Lambda terms concurrency mean? It means the number of Lambda instances raised up and running in the parallel. It's not about thread inside the Lambda, it's about Lambda instances. And as you can see here, number of the number of the running instances, it isn't, for example, 10, but only in different moments it's 3, 5, 4, 6, etc. And if you have a look here, you can see hot start for the first Lambda when the first request was handled, response sent back, and one more request arrived. And you can see that even if, for example, Lambda processed 10 requests, but the maximum concurrent number was 6. 1000 is a default number of concurrently running instances of the Lambda on account level. Account level means on account level, and 900 it's maximal number of concurrently running Lambda instances for one Lambda, for one function. We couldn't run more than 900 instances of the same Lambda function. Few words about reserved concurrency. What does it mean? It is possible to reserve for one or two Lambda functions number of Lambda instances that would be raised up anyway. Here on the image you can see that there is reserved 400 Lambda instances for blue function and another 400 for the orange one. Yeah, and when we reserve for any function number of Lambda instances, it means that even if these Lambda functions there were no event and they not running, but other Lambdas couldn't be raised up and start if their number became higher. On the image between T3 and T4, you can see that number of the running Lambda instances is 400, and AWS doesn't allow to run more Lambda instances for the reserved concurrency, even if we have free numbers in another reserved function or for all other functions. The same situation is here. We have that all free Lambda instances is run up common, but we have free reserved instances for blue and for yellow, but no one of them will be raised up, and in this case either some requests will be missed or the response will be sent during the very long period, but it is impossible to use free Lambda instances reserved for the functions. The several words about provisioning concurrency. In my mind, provisioning concurrency makes Lambda not serverless, but let's have a look. What is provisioning concurrency? Provisioning concurrency is when AWS service starts Lambda function, even there is no event to which Lambda is subscribed. It does mean that Lambda behaves like any application service. It runs all the time long. This allows to, and this Lambda's invocation always will be hot, but of course you will pay for the whole time when Lambda is running. And that's why I'm thinking that Lambda, when provisioned concurrency is used, Lambda became not serverless, yeah, in some way. And unlike of the provisioned concurrency, if the maximum number of unlike of the reserved concurrency, if number of instances of provisioned concurrency is used and you need to run one more Lambda instance, AWS allows to do this, but for this instance, first will be invoked in initialization and Lambda function start won't be hot. Code reusability, I already mentioned that there is Lambda layers. In this, there are several of the purposes of having them. We can put some code inside layer, and one layer could be used by different AWS Lambda function. Also, it's a good place to put libraries, binaries, and of course, this allows to speed up deployment and development. Versioning CI/CD. Versioning means that it is possible to have several versions of the same function. The function version includes code, its all dependency, its runtime and extension that executes the Lambda function, all settings and environment variables. And versions are immutable. It is impossible to change already created version. The only way is to update it is to create new version. And the only changeable version is latest version of the code. Why do we need versioning? Here, one more thing connected about Lambda functions. It's function alias. Alias is mutable, and it could point to any of the function version. Here you can see green and blue one, and it points to two different function versions. And this can allows to divide traffic. For example, when we run new recent function and we would like to have canary release, we can move one part of the traffic to new Lambda version, have a look what's going on. In the same time, the main traffic will go through the old versions, old stable version. And when we will be sure that new version is okay, we can move all traffic there, just updating alias settings. And developers, of course, works with the latest function version. For building and packaging and testing and shipping Lambda could be used different kind of solutions. For building and packaging, we can use GitHub, GitLab pipelines, Circle CI, TeamCity. Of course, it used Maven. There is plugins for Maven, for Gradle. And of course, AWS provides their own solutions and its integration of different services like code pipeline, code commit, code build, code deploy, etc. that allows to implement and run all development life cycle using AWS services. And yes, of course, we have AWS SAM. I will talk about it a little bit later. And one more, of course, it's when we run AWS any services and Lambdas as part of it, it's all about infrastructure as a code. And AWS provides CloudFormation for these purposes and AWS SAM. And also there are other tools on the market like Terraform or serverless framework, but serverless framework is only about Lambdas. It's not about other AWS services. And when I used it, it was several years ago, there were troubles of subscribing Lambda to different other services like S3 buckets. But I hope that it was already fixed. Here you can see example of the code pipeline implemented on AWS services. When developers, here we can see a development account and production account, and AWS provides the full number of tools to implement pipeline, like code commit when code is committed. One more, AWS Lambda, run code pipeline, pipeline runs code build, CloudFormation, and put it into the development account. It could be tested, and then the same flow for master code pipeline and production. Of course, Lambda provides some tools for monitoring and troubleshooting. First of all, it's AWS Lambda console, but it's concentrated mostly on the things that somehow connect to money that you have to pay for it. It's invocation, durations, error counts, success rate, etc. Of course, we have CloudWatch, which allows to track a lot of different metrics. Also, it provides Lambda runtime metrics, logs, and CloudWatch alarms. CloudWatch alarms, it could be used, for example, if something goes wrong or any exception. You can just subscribe one more Lambda to it and send event, for example, to SNS topic or send via SES service email to somebody to notify about the error. Also, there is AWS X-Ray. It's tracing tools to trace event across AWS service, for example, from Lambda to microservice, or if you have several Lambdas invoked one by one in a row, you can trace it. etc. Code Guru Profiler allows to profile Lambda runtime and sites. It's not AWS tool, but it exists on the market. And one more really powerful tool, it's not only about Lambdas, but about all AWS environmental and all AWS services. It's Datadog. It's a SaaS platform for monitoring and analyzing AWS metrics. Also, I would like to mention that CloudWatch logs is really very easily could be integrated with for different log tracking system, for example, ELK, Elastic Log Stash Kibana, and all data from CloudWatch could be imported to Elasticsearch, and it could be viewed in Kibana after that. So AWS SAM is serverless application model. It consists from two parts. The first one is AWS SAM template specification, and the second one is CLI. From my point of view, they're really good, and it's really big step forward. If we will have to sample on the right side of the AWS SAM template specification, you can see here the code to run infrastructure from this image. We have here gateway, we have here Lambda function, we have here DynamoDB, and it's only about 20 or 30 lines. If somebody worked with AWS Cloud Formation, I think they know that to run the same services and describe the same services, you will need hundreds of lines. And in my mind, we can make a parallel between AWS same template specification and Spring Boot applications. When Spring Boot application set allows to avoid of extra configuration for default services, you just have auto configuration, enable auto configuration, and Spring Boot run everything for you. The same thing is about AWS SAM template specification. You don't need to dive into details that you don't need. Yeah, you can just specify only those what you need. Yeah, and it's much shorter. The second part is AWS SAM command line interface. It's tool that allows to support third-party integration to build and run serverless application. It allows to create a new project, to build application for deployments, perform local debugging and testing, deploy application, configure CI/CD deployment pipelines, monitor, and synchronize local changes to the cloud. Of course, AWS SAM used other AWS services like pipeline, could be built, etc., etc. But from my point of view, it's the main feature of it is that it allows to debug and test Lambdas locally. And debugging, AWS SAM provides toolkits for Visual Studio. And also it provides toolkit for JetBrains different tools like Node.js for Python, for Java, for Ruby, for Go. And also there is AWS Cloud 9. It's on-demand AWS on-demand IDE, but it supports only two languages, Node.js and Python. Best practices. Keep business logic outside the handler. It's easy. I mentioned that there is no any architecture or something to keep code separately inside Lambda function. You have only one file, but you can create several more. And it's really good idea to keep business logic, at least to be able to test it without mocking of Lambda events, etc., etc. The second, warm containers. It's just a suggestion to take advantage of execution environment reusages. For example, you can keep inside libraries or inside Lambda layers, libraries or connections to other services that could be reused during hot start, and you won't need to establish new connection because creating new connection is pretty expensive operation, and you can avoid of doing it every time when Lambda raise up. Keep alive directive allows to maintain persistence connection, control dependencies inside deployment package. In other way, we can say that everything that Lambda needs to run, it will be great to put it inside the Lambda package to avoid of issues with different versions, etc., etc. Use environment variables to pass operation parameters. It's, I think, not about Lambdas, but it's about any application. If you would like to tune any application without code change, you have to do this. Trim dependencies. Also, it's not only about Lambdas, just to load and keep only those things that you need. Keep libraries. It's about keep libraries in separate jars and reduce the time it takes Lambda to unpack deployment packages authorized in Java. It means that for Lambda service, much easier to unpack several jar files than find one jar inside another, etc., etc. Fail fast. Fail fast, it means that, for example, if you have Lambda functions that invokes any other third-party service, and for some reason this service don't respond for a long time, and it makes sense to fail down without waiting of response, because nobody know how long it will take, but you will pay for this time of waiting. Minimize complexity of your dependency. I think it's also a common thing, and as well as writing idempotent code where and when it is possible. Yeah. And last practice that I would like to mention, it's avoid recursive code, because penalty it's some kind of stack overflow of running Lambda functions instances. For example, when you start recursion and you couldn't leave it, yeah, and you create one more instance of the Lambda function, and you will create a lot of and you will create 1,000 Lambda instances, and of course you will pay for it. Might be that's it. Thanks for listening to me, and any questions are welcome.
Thank you, Yaroslav, for your presentation. Yeah, we have a few questions, so I'll start with the first one. Can you share insights into the monitoring capabilities of AWS Lambda? What tools and features are available for tracking and analyzing the performance of serverless functions?
Mm, As I already mentioned, one moment, I will find it on the. As I already mentioned, AWS X-ray will allow to uh, to track AWS Lambda performance, and also there are a lot of different extensions that already written, and you don't need them, and they allow us to monitor everything inside Lambda, and it allows to monitor different steps when Lambda raised, when it shut it down, uh, when, for example, different parts are loaded, etc.
Um, Thanks. And the next question. Can you describe typical integration test for Lambda which write to Aurora?
What unfortunately couldn't answer back, but typical integration tests for me, if it is integration, you have to run Aurora, and you have to create, might be, it would be third party application, like, no. From Java world, I will use Cucumber, which will invoke your Lambda with the within the AWS, within the Aurora service together. But yes, in my mind, it could be done this way.
Okay, thank you. Next question is, does RDS proxy help with pulling connections from Lambdas, or some bottleneck are still possible?
Uh, could you say it again? I missed one word. Does what?
Does RDS proxy help with pulling connections for Lambdas?
RDS with pooling connections? Uh, I don't think so. I know that there is Aurora connection pool for database, but I haven't seen, for example, for Postgre and for MariaDB. It's databases I worked with. And no, RDS itself doesn't help with connection pools. Or I missed something, but I don't think so.
Do you use Java native?
No, I used. I can say that yes. For on one project we used Java, but it was a really special case, and it was a Lambda. Let me go back here. It was this Lambda that checks logic of providing authorization check logic. Yes, and this Lambda was invoked really lot of times, and it almost always was up and running. So we don't need to care about creating Java JVM because this run is not very fast. And in all other cases, it was Python.
Thanks. What I should use if 15 minutes not enough?
Mm, Enough for what? And which case? I don't have a lot of inbound data, but let, let's think that we are talking about that one Lambda running for 15 minutes. In my mind, it's really too long. I'm not remember from I don't have in my head the maximum time of Lambda running. Might be it's about 5 minutes, but definitely it's something goes wrong. Lambda isn't intended for such long runs, and if you have functionality or requirements for such things, I think you should have a look to another instruments, not to Lambda, or divide it somehow.
We got a little bit of context. For example, I need to run code 30 minutes to reindex Elasticsearch job.
Mm-hmm. I see. I don't know. In my mind, personally, me, I will try to do this not by Lambda or make it, for example, in async way. Yeah, when you just start reindexing, because when you start reindexing and subscribe to its end or to its error, if it is, of course, possible. For me, I don't think that AWS Lambda is the best tool to do this.
We have another question. What are the best options to resolve cold start apart from provisioned concurrency?
Uh, could you say it again, please? What is
Best options to resolve cold start apart from provisioned concurrency.
but provision concurrency is about hot start, and if you have provision concurrency, several lambda, you specify which amount of lambda are running always, and all invocations to these lambda functions will be hot invocations, not cold. And if you have, for example, you have 10 Lambda instances running and waiting in provisioned concurrent as provisioned concurrency, but in one moment you need not 10 instances but 20 instances, and the rest 10 ones going through cold start. Might be in this case you could just change threshold number of provisioning concurrency Lambda function.
Thank you for response. We do not have any questions yet, and I suppose we can wait for a few minutes if anyone has any questions. Yeah. So guys who are listening to us now, if you have still any questions, you can write it now and we will also read them and Yaroslav will respond. By the way, we will send you the record of the event soon, approximately in 24 hours. So you will be able to watch the presentation again. So we have another one question. But if I don't want to pay for full or for provisioned concurrency?
There are tricks to keep Lambda running. For example, just sending requests for it, etc. But in my mind, it is the same. The same. And for Java world, you have one more option. It's about snap start. Yeah, when Lambda starts from the memory. Am I answering your question?
We do not have any other questions so far. I think, oh, yeah, we got one more. Is it possible to execute some operations in Lambda using custom executor services or thread pools defined in Lambda? How many threads can be used in this case? Are there any limits?
Oh, let's go one by one. Could you repeat it, please,
Okay,
again?
is it possible to execute some operations in Lambda using custom executor services or thread pools defined in Lambda?
Mm, I think no. Uh, Thread pools inside Lambda itself, exactly no. But you can create extensions and it will be executed, but it will be executed only during Lambda, when Lambda is up and running. Next question, please.
How many threads can be used in this case?
Sorry, I couldn't answer on this question. I don't remember such an information.
Are there any limits?
I think yes, they are, but from the head, I don't know about them. Is it the last question?
Yeah, there are no more additional questions about that topic, but I think we can wait for a minute or two if a person who asked this has any other additional questions about this.
Sure.
Uh, have you ever used local stack?
Local stack?
Yeah, local stack.
Yes, but not in production. Uh, Not in production project, because my last production project was in 2020. But when I have read about SAM, I used it. I just raised it up, and it was really interesting for me to try to debug in local, because previously when I tried to implement to do this by my own, I put it Lambda to Docker container, but it wasn't very really handy. And also I used AWS Cloud 9, but it's not JetBrains the it's worse.
Okay, thanks. Let's wait maybe one more or 2 minutes and see if that's all.
Sure.
So as I can see, there are no more questions. So thank you everyone who joined us today. I hope that information you have heard was useful for you, and join us please for our future events. And thank you, Yaroslav, a lot that you shared your knowledge today and answered all the questions. We would be really happy if you joined us more for our events and shared your knowledge even more. So thank you, everyone, and have a nice day. Bye.
Thank you. You too. Bye.